Okay, so this is going to be the question 6 of the A-Level Pure Mathematics 2 October 2020 paper. So you can see here we've got an integration question. So it's going to be question 6, and it's going to be given that this is equal to this here. Yeah, so some undisclosed other form of the equation. We need to find the constants A, B, and C. Okay, so this is similar to a partial fractions question. It probably does come under the topic of partial fractions. I guess with partial fractions, usually you'll see something like this where you've got multiple fractions, but I guess it's still the same thing. So essentially the first order of business is to try and get this into this form where we know A, B, and C. Okay. So what we're going to do is essentially we're going to convert this to try and look like this. And then we can use a method called equating coefficients. Okay, so what this involves is essentially just writing out the question as it currently is, which is something I always recommend. It's always good to do that just to get the problem down on the page and get yourself started writing. And now we want to try and get everything over x plus 2. Okay, so in order to do that, we need to basically divide each of these terms by x plus 2. Now, the problem is we can't just do that like I've written. Okay, we have to make sure we adjust each of these terms so that they stay the same. Because if we just put an x plus 2 on the bottom, they're no longer the same. So what we're going to do is we're actually going to divide and multiply by x plus 2. So effectively, we've done nothing to them. We've just changed the way they look. So what that looks like is this. So ax, x plus 2, plus b, x plus 2. Now the c doesn't need to be changed because it's already got an x plus 2 on the bottom. And then we can put all of this over x plus 2. Because if we were to actually work this out, let's say we were asked to simplify what we've got written here, that would cancel, that would cancel, that would cancel, and we're left with the same thing. Now this x plus 2 wouldn't cancel with this, but you get my point. So the next thing to do is to expand. So if we expand the top of the equation, we're going to go ax squared plus 2ax plus bx plus 2b. And then we've also got the plus c on the end as well. So what you'll notice is that this is all over x plus 2. I'm not going to write that, but now it's actually in the same form as this. So what we can do is we can say, well, we know that this must be equal to x squared plus 8x minus 3 because they're equivalent. Okay, that's what it says in the question. So essentially now this is where we start equating coefficients. So we need to collect some terms first. Okay, so if we look at the x squared term, we can say, well, ax squared must be equal to x squared. Okay, and we know that the x squared has a 1 in front of it, so we know for certain this one's nice and easy. A must be equal to 1. Okay, so next we can look at the x terms. So we've got a 2ax and we've got a bx. Okay, so we can actually say 2ax plus bx must be equal to 8 because that's the coefficient 8x, because that's the coefficient of the x term. Okay, so we know that a is equal to 1, so we can actually straight away change that. So 2 times 1x is going to give us 2x plus bx is equal to 8x. So we know that 2 plus b is equal to 8. So that b must be 6. B equals 6. Okay, so final one now, it's going to be 2b plus c. And that's going to be equal to minus 3. And again, we know the b this time, so we can say 2 times b plus c equals minus 3. Do the calculation, it's going to be 12 plus c equals minus 3. C is going to be minus 3 minus 12, which is minus 15. C equals minus 15. Okay, so I guess we've completed the question as it's been asked. So what I'll do is I'm going to write a is equal to 1, b is equal to 6, and c is equal to minus 15. And then I'm going to get rid of everything on this side so we can do the integration. And then everything on this side as well. Might be quicker if I just do this. So get rid of all that. There we go. Okay, so now that we've got this, we can actually do the integration. So this wouldn't be particularly easy to do an integration on. Okay, so for part B, we essentially need to have it in the form that we've just converted it. So essentially the equation becomes x plus 6 plus, or should I say minus 15 over x plus 2. Okay, and we've got to take the integral of this between 6 and 0 with respect to x. Okay, so I think the first two terms are reasonably straightforward to integrate. So add 1 to the power, divide by the new power, gives you x squared divided by 2. And again, this one's pretty simple, just like that. Now, this next one can be a little bit tricky. Okay, so what we need to understand for the next one is that whenever we take the integral of, let's say, some constant over some constant times x plus some other constant with respect to x, essentially the constant k comes out and it doesn't really participate. So we just multiply the k by whatever we get next. Now, the thing that we get out is 1 over a times the ln of ax plus b. Okay, now the reason why we have this 1 over a is because if you were to differentiate this, you would differentiate inside of these brackets, giving you a, because the x would be chopped off, the b would disappear, and you'd be left with a times by a. So in order to counteract that, we need to add this divide by a, or this 1 over a, when we integrate. Okay, so this is the rule that we're going to apply here. So you can actually see that this is our k, the 15, or the minus 15, and then the a is actually 1 and the b is 2. So what this comes out as is we get minus 15 times by ln of x plus 2. So this 1 over a is just 1 over 1, so that doesn't really make a difference. So minus 15 times 1 over 1 times ln of 1x plus b. So it's essentially the same thing. That's where it all comes from. Okay, so I'll get rid of these now just to tidy things up. And then essentially we've got to apply the limits, which we haven't done just yet. So we're going to add a 6 and a 0. And the way that we do this is we substitute in the limits and subtract the bottom limit from the top limit, essentially. So 6 squared over 2 plus 6 times 6 plus, or keep doing that, should I say minus 15 times ln of 6 plus 2. I usually put all those in brackets, and then we're going to subtract. Now this one does become quite easy because we get 0 plus 0, because 0 squared is 0, 6 times 0 is 0. So you can basically just say straight away 0 plus 0. Now we've got to be careful with this one, because sometimes people just assume that because the limit's 0, the whole of this side for this 0 limit just disappears. Well, that's not true. So we essentially have to sub in the 0, and we get this. Okay, so if we simplify, we get 36 over 2 plus 36 minus 15 ln 8 minus 15, well, minus 15, so plus 15 ln 2. And then essentially we can simplify this. So 36 over 2 is going to be, I mean, we can write this, I like doing this, just write it above like that. 18 plus 36. And what does that give us? That's going to give us 4 on there, 54. That's equal to 54. So then we can actually write that down. You can write 54. And then this is where it gets a bit more interesting. We've got to do some manipulation here. Plus 15 ln 2. We can actually, and I'm going to do this in pink above this here, we can actually write this as ln of 2 cubed, which is the same as 3 ln 2. Okay, so that's quite handy to know. So then if we actually apply this, we get 54 minus, now remember it comes out to the front, so it's going to be 15 times 3 ln 2 plus 15 ln 2. And then we can combine everything together and get our final answer, which is going to be 54. Now this is going to be minus 45. Okay, so that's going to be 45 or minus 45. Plus 15 is going to give us minus 30 ln 2. And what you'll notice, and this is a good habit to get into, is look back at the question and see what they've asked you to give your answer as. So they'll say here, give your answer in the form a plus b ln 2, and we'll see that we've got a, now it's plus a negative number, but it's still in this general form, ln 2. So we know we've got that completely right. Okay.